Here we're going to be looking at Leetcode 125, valid palindrome. We're told that a phrase is a palindrome if after converting all the uppercase letters into lowercase letters and removing all non-alphanumeric letters, it reads the same forward and backward. And alphanumeric characters are basically letters and numbers. So we're going to be given a string, and we have to return true if it's a palindrome and false otherwise, and we're given a description of what palindrome is. So in this example, a man plan a canal, Panama. So if you remove all the special characters and spaces, you'll find this is actually a palindrome, so we return true. In this example, race a car is not a palindrome, and an empty string is a palindrome after removing all the non-alphanumeric characters, so we just return true. And we're given some constraints. We're told that S consists only of printable ASCII characters. So the way we can approach this problem, the solution we're going to use is using a left pointer and a right pointer, so a two-pointer solution. That's comparing each value to the value each value at pointer L to the value at pointer R, and if they are not alphanumeric characters, then we skip them, and then we compare the two values. And if they aren't equal to each other, then we return false. And if they are the same, then we can carry on going until we get to the midpoint, after which we know that we have found our string being a palindrome, and we return true. So let's hop into the code. Let's set our left pointer equal to 0 and our right pointer equal to length of our string minus 1. And we're going to check that our pointers don't cross each other. And now let's check for any non-alphanumeric characters from our left side. So we'll say while L is less than R and not SL dot is al num. So this function in Python will return true if our string is alphanumeric, otherwise it won't. Otherwise it will return false. So if the character that we're at is a non-alphanumeric character, then we want to say L plus equals 1. So we want to increment our left pointer. And then we want to do the same for the right pointer. So let's say while R, we can kind of just keep the same logic. Let's flip it around. Let's say while R is greater than L and not SR dot is L num, we'll say R minus equals 1. So we'll decrement our pointer, and then we need to compare the two lowercase versions of our current characters that we're at the index of L and R. So we'll say if SL dot lower does not equal SR dot lower, then we can return false, because since they aren't the same, we know that the string can't be a palindrome. Otherwise, let's carry on incrementing our left pointer and decrementing our right pointer. And then if we finish the while loop without returning false, and now we know our string is a palindrome, so we can just simply return true. So let's run our code. And let's submit our code to make sure it passes all the test cases. We pass all 486 test cases. So in terms of time complexity, it's a linear single pass from either end. So the time complexity is going to be O of n time complexity, and space complexity is going to be constant space. So it's going to be O of 1 space complexity. So I hope this video made sense, guys, and I'll catch you in the next one.